This example comes out of section 10.1, Sums and Differences of Functions. So in this example we're asked a very similar set of questions we were in the last, the sum example that we did in example 1, but this time it's a difference. So h of x equals f minus g of x, or in other words, f of x minus g of x, which is a far simpler way of writing it. I'm not sure who came up with this f minus g of x system, but I use it only because I want to make sure you guys recognize it. So h of x is going to be square root of x minus 3 minus brackets x plus 5, or if you're putting this into your calculator you might not want all those brackets, so you'd say minus x minus 5. You have to subtract that whole second function. So sketching them on the same set of axes, again your calculator does provide you with some help with this, but we should be able to sketch the first couple for sure. That this first one is a radical function that's been moved 3 to the right, so there's f. X plus 5, 1, 2, 3, 4, 5 is a plain old straight line with a slope of 1 even, so it looks something like that. Now, h of x you might want to put onto your calculator, because I don't expect you're going to know that one off the top of your head, but it is a curve, and it does look something like this. Now that's obviously not the most accurate curve you ever saw a person draw. It, looking at your calculator, somewhere around -8, which if you look closely you'll see that this point actually is, this point here is 3, 0. On the g of x it's 3, 8. And so if you do 0 minus 8, it makes sense why this point is -8. But it actually does go up slightly and then down from there. So you've got this, so the domain is not particularly hard, because the domain actually turns out that it's the same domain that f of x has, which is that you can't square root a negative number, means that you have to be greater than or equal to 3. Other than that, all real numbers are just fine. Now the range you almost have to estimate by looking at the screen, but if you play around with your cursor a bit and do a maximum, you find that the highest this graph goes here is roughly -7.75. So the best we'd be asked to do at this point right now is to say, well, the range is everything below that, so y needs to be less than or equal to -7.75. And it does continue decreasing from that point on. So kind of an interesting question, a little bit different than the sum. And notice that if we did come up with a different function that was called g minus f of x, that would not be equal to f minus g of x. Even though when you're adding they were the same, but the same way that if I say, what's 5 minus 3? That does not equal the same thing as 3 minus 5, even though when you add them, it doesn't matter what order you do it in. So same thing is true here with the functions. Usually if you do subtraction, it matters which order you put them in.